We'll be moving to the next topic, that is embedded system hardware. So we have already completed two topics, that is RISC and ARM design philosophy. Now we'll be going for embedded system hardware. Once it is done, we'll study about its software and then continue to the next topic. So you have to know the four things about this embedded system hardware. So before you move on to the directly to the main four hardware components, we'll just read a small definition for this. Embedded system controls various devices and uses a combination of software and hardware components. Each component is selected for efficiency, cost effectiveness, and scalability. A combination of like hardware and software components. It's a topic which you will be facing in your fourth or fifth module. So basically the subject is not that difficult, because once you learn something from the first module, it will be repeated in the further modules, and it's not that complicated or difficult to remember or understand. It's kind of easy itself. So if you have to, you just have to believe that it's easy. If you think in mind it's too much, there are so many points, then it will only panic and complicate the stuff, nothing else. So main hardware components of an ARM based embedded device. Okay, so it has ARM processor, controllers, peripherals, and bus. So what does the ARM processor do? See, it controls, okay, it processes the instructions, and it also interfaces with the bus. So this should be able for you to like understand or remember easily whenever you look at the PDF. And then see, it has controlling the system, controls the system, processes the instruction, and interfaces with buses. You have to know few things about this ARM processors. What are the controllers for? It is also a component. What does the controller component do? It manages functional block like interrupt and memory. So interrupt and memory are nothing but they are the functional blocks. You have to remember this. Okay, sorry, underline manage as well. So functional blocks are being controlled over here, or sorry, are being managed by controller. So those are nothing but interrupts and memory. Peripherals are nothing but it enables input and output operation and define the device's uniqueness. If you don't remember this, it's fine. You just have to remember it enables input and output operation. Bus is nothing but they facilitate communication. You always know register and memory. Like between different hardware components. Usually bus like communicates, as you can see it interfaces with the buses. What is that? ARM processor. So it is also a hardware component, right? And register it different hardware components. So register and ARM processor are linked with bus and all stuff like that. ARM bus technology. So embedded system uses one chip buses instead of external PC buses like PCI. So now ARM bus technology, it has a bus master. What a bus master is nothing but it initiates the data transfer. Like it's like a head. If something has to be transferred, so it starts the transfer. And the bus slaves, there are multiple slaves. So whichever slaves is free or should a particular slave, they'll be respond to the transfer. Like if I have to save in RAM, ROM, or like particular things are there, right? And some slave might respond to specific thing, and some like if some is busy, the other responds like that. So bus slave responds to the request, that what the master has start. Okay, and then we have buses have two levels. One is the physical level, and another is the protocol level. The physical level is nothing but they are all just electrical characteristics and widths, like 16-bit, 32-bit, and 64-bit, like that. So that's the physical level. Physical like hardware stuff and all. And the protocol level are nothing. See, protocols, you should always remember when you hear the word protocol, it's nothing but it's a set of rules to be followed under certain circumstances. Okay, pardon my like I'm just not pronouncing few steps properly. It's just because of cold, so don't start making fun of it. Protocol level, see, rules governing a processor to peripheral communication. So processor peripheral communication, you should peripheral. Okay, so you will be knowing about this, just give me a moment, I'll you will understand about this peripheral thing just below. If you continue studying, ARM primarily specifies bus protocols but rarely implement. Okay, so this is a diagram from the textbook. You have an example of ARM based embedded device, a microcontroller. I don't think they'll be asking this one, but you can also like get a simplified diagram from the internet and use it. So AMBA bus protocol. So advanced microcontroller bus architecture is nothing but the abbreviation of AMBA. It is a protocol which was introduced in 1996. It benefits what enables reusability of peripheral across projects, provides plug and play capability for hardware designer. See, I'm just not reading it. I'll also explain to you. See, if you talk about peripherals, hmm, see, peripherals are nothing but they provide the input output functions for the chip. Okay, so the input output functions can be reused. That's what they are just telling over here. Plug and play capability of, again, that I don't know, but you just have to remember it, right? Types of AMBA buses. So see, there are one, two, three, four types. Okay, and further this, usually like not four, five. So you have to remember ARM system bus. So a system bus and peripheral bus. See, just the word system is additional, like ARM bus. In that only system is being added in the middle, and here peripheral is just highlighted S and B like that. They are the like earlier buses. Later, high performance buses came, which have the higher data throughput in the sense like gives the output like time taken to give an output is nothing but throughput. Okay, it supports 64 and 128 bits. See, it's too much, right? Usually we have just seen about you know 32 and 16 and stuff, but here it is 34 and 128 bits. Multi-layer AHB, again a high performance ARM high performance bus. It has bus. See, multi-layer is nothing but it has multiple bus master, and AHB light is but it has just simple version of single master. That's it. Example, AHB for high performance peripheral, like peripherals, right? Input output operations. APB for slower peripherals. AC P is what? ARM peripheral bus. AHB ARM. This is bus. H stands for high performance. Here see ARM bus. P stands for peripheral. That's it. External bus requiring a bridge to connect with AHB. Memory. Okay, so let's talk about memory. Embedded system require memory for code storage and execution. See, you have to save codes and then you have to execute them. If you are a software developer or a web and or app developer, you will understand it much more easier and better, but we'll keep moving. So there is a hierarchy of memory. Hierarchy in the sense like from which level to which level, like, or like flow of things stuff. So first the cache memory, from it to main memory, then from it to secondary storage. Cache is the smallest and the fastest, whereas the secondary storage is the slowest and the largest. You understood, right? First and last is the exact opposite. In the middle, it's just average type, lowest, larger and slower type. Okay, cache improves speed but reduces predictable execution time, and it is not ideal for real-time systems. And cache can sometimes be cleared as well. So cache memory is not suitable for real time because it does not give you the updated real data values. Instead, it gives you the stored data stuff and all. Sometimes you can also check with your Instagram stuff and all. When you open the if there are no internet connection, the whatever the data was stored in the cache will be visible, but you cannot read the remaining stuff and all. Memory width, it's nothing but it's the size, like, okay, fine, let me understand. Memory width affects the performance and cost. For example, you have a high bit instruction, but you have a lower bit memory, so it requires multiple fetches. But whereas if it is like the instruction and the memory are the same bit, or the memories are of higher bit, then it requires less fetch. You can see this diagram. Instruction size ARM 32-bit and thumb 16-bit. 8-bit memory, 4 cycles, 2 cycles. Yeah, it's like 8 to the 16, right? I understood, right? 16-bit memory, see, 32-bit, 2 cycles, 1 cycles, because it has to like it can only process 16-bit at a time, so it has to process 2 times to complete 62. 32-bit memory cycle, see, 1 cycle, 1 cycle. What I said, equal or more gives you just 1 cycle. Less than equal is nothing but multiple cycles, like that. Then you have memory types. You have ROM, read-only memory. Flash ROM, it's nothing but little bit slow than the ROM. DRAM is nothing but the most common RAM. Requires refreshing, low cost. SRAM is nothing but static RAM. It is the fastest, it is faster than RAM but more expensive. SDRAM is nothing but synchronous DRAM, synchronous dynamic RAM. It has higher clock speed and it synchronizes with the processor. See, ROM is always permanent. It is used for boot core and stuff. Peripherals provides input-output functions for the chip. All ARM peripherals are memory mapped, which means it is controlled via memory addressed registers. There are two controllers for this. So there are memory controllers and interrupt controllers. Memory controllers is just connects or maps memory types to the processor bus. Some memory devices require software configuration before use. Example DRAM. But in interrupt controller, you have two more subtypes. It manages interrupt signals from peripherals. There are two ways how it manages. One, it sends an interrupt signals. Another, it prioritizes the interrupts and gives the direct handling, reducing response time. You understand? One, it sends the interrupt signal to the processor. Software reads a register to identify the source. That is standard interrupt controller. Whereas in vector, it prioritizes the interrupt and gives the direct handling, by reducing response time. So that's all you need to know. I can just look into these questions. We'll be moving to the next topic.